Good morning, guys. It is a great day to be in room 625. It is. Today we're going to continue working with inequalities, but we're going to work on solving multi-step inequalities today. Let's look at a couple examples. First off, before we actually do the example, solving inequalities is the exact same thing as solving an equation. Just kind of imagine that's an equal sign, and we're going to treat this the same way we treated our last unit, and solve them the same ways. Goal, get our variable on one side and get all of our constants on the other side. So first one's really simple. We have 6x minus 7 is greater than 2x plus 17. Step one, let's get all of our variables on the left-hand side. Minus 2x, minus 2x. My 2x's cancel out. That leaves me with 4x minus 7 is greater than 17. Now that I have all my variables on one side, I want to get all my constants to the other side. So I'm going to add 7 to both sides. Add 7, add 7. My 7's cancel out. That leaves me with 4x is greater than 24. Now that I've isolated the variable term, I need to actually isolate the variable itself. So I'm going to undo the multiplying by 4 by dividing both sides by 4. I'll get my answer of x is greater than 6. So that's my solution. Time to graph and come up here to our line. I'm going to make a spot for the number 6. I am going to graph my circle on it. It's going to be a hollow because there's no equal to sign. And I want the numbers greater than 6, so those will go to the right. So that is the graph, that one right there. Next one says negative 6y plus 5 is less than or equal to negative 25. Step one, get all of our variables on one side. We already have all the variables on the left-hand side, so don't need to worry about that. Step two is to get all of our constants to the right-hand side. So I'm going to subtract 5. Subtract 5. My 5's cancel out. That leaves with negative 6y equals a negative 30. Now this is not equal, sorry. Less than or equal to negative 30. Now this is where be careful. We talked about this in class on Tuesday. Solving inequalities are the exact same thing as solving equations, except when we divide both sides or multiply both sides by a negative number, we have to flip the inequality sign to keep that statement true. So I'm going to divide both sides by negative 6. Divide by negative 6. That's going to leave me with y. It's going to leave me with a positive 5. But I have to make sure I flip my inequality sign so it's facing the other way now. So it's now going to be greater than or equals to. That's my inequality. When I go graph it, I make my spot for 5. I circle it. I need to fill in my circle because 5 is part of my solution set. And it's going to go to my right as well because I want all the numbers greater than or equal to 5. So 2 examples down. Let's do another one. The next one I have is 2x minus 3 is greater than 7. Just like the previous one, this one also has our variable already by itself. There's no x's on the right-hand side to get rid of and no x's on here to combine. So step one will be to just add 3 to both sides. Add 3. Add 3. Those cancel out. I'm left with 2x is greater than 10. I've isolated my term. Now I need to isolate the variable. Divided by 2. Divided by 2. I get the solution x is greater than 5. Come over here, graph it. Make a spot for my 5. Circle it. No, I do not fill it in because there's no equal to sign, so it's not part of my solution set, and I want all the numbers greater than 5, so it's going to go to my right.